Okay. So the idea today is for me to talk to you about how we test at Nubank at every level of the application. Okay. And before that, I'm giving you a little bit of context on Nubank. That's like is a fintech, it's a digital bank that launched in Brazil 6 years ago, launching a credit card, and now we have like a checking account and lending products, and we grew to. Yeah, we have like several products here, lending, and we launched Mexico last year as well. So we have like now a beta product launched in Mexico. We have more than 20 million customers in Brazil, and a couple thousand in Mexico until it's still beta there. But like we have billions of messages, billions of requests, tens of deploys a day, more than 350 microservices, more than 500 engineers. Several shards, several teams that like this scale itself is very hard to manage, very hard to grow. And in order to be able to grow and evolve rapidly, we do need to have a good testing suite. And this talks about like all the levels of this testing. And also a little bit on context on how our system works. We run a microservices architecture, so we have 500 services, so my microservices here. And the idea is like we have all those services grouped in a way that we have like products, so we have services that solve for credit card, we have services that solve for the checking account, and service for lending. And even inside the credit card, we have several domains inside the credit card. So every domain has its own platform that we're calling like the domain platforms. And we have like product services as well to implement specific product. Like the credit card in Brazil and credit card in Mexico are a little bit different. So we have a generic platform to solve for both, and a product service that solves for the Mexican credit card, and one for the Brazilian credit card in some aspects. So, and we look at all those microservices as they were like Lego pieces. They look about the same. The architecture we chose, all the services look like the same. We can see every service as a function if we are calling them via HTTP. We can look at them as a channel with transducers if you're looking through Kafka Messages. And every service looks like the same, use the same design, the same architecture. Okay, Gabriel here can testimony on that because he was there 3 years ago. So, and we use this that we call now the diplomat architecture that's based on ports and adapters, but focused on functional programming. And we have the ports that are the communication between the services, the way that service communicates to the external world. We have the adapters that they are the handling functions for from those ports. So the function that handles the HTTP request or the function that handles a new Kafka message are this adapter layer. And these functions basically delegate to the next layer, that's the controllers. And these controllers basically wired all the business logic to the side effects. So all the side effects are done via the ports and the adapters, but the controllers wire those logic. And we have the pure functions that are the actual business logic that are run on the service. And this business logic done via pure functions is the major like power of this architecture, because it's the most complexity is around the business logic. And the pure functions are the simplest construct that we have on Clojure, for example. So we use the simplest construct to handle the most complex part of the system, so we can tame that complexity in a better way. Okay. And at the end, we have the service that is the deployable unit that we put on production. Okay, so the service in this case, we can like map one-to-one to the microservice, but it's actually the deploy unit. So how we deploy that code to run in production. The service could be a Lambda function, for example, or this service can be a Docker container that runs in Kubernetes or something like that. Today we only run services on Kubernetes, Docker container, Jetty, or something like that. But like we could have that same concept if we were running like Lambda functions on Datomic, Eon, or something like that. This architecture would work. Okay. And the idea here is that we'll show you. I'll show you how we test each of these layers. Okay. And which tools do we use? The first one is the pure functions. There are like normal Clojure functions that we can write specs on it. So in our case, we still use the Plataformatec schema library, not spec yet. We were waiting for the new version to make sure if we can move to that. But like since most of the code is already on schema, we are using schema. But specs the same. We can build invariants on this kind of functions if we want to. We can write generative tests or this automatic generative test that spec can give you. We can do the example-based test, like write a normal test that asserts a given example. And this, like, we can limit the complexity we are handling on that function. So it can be as big as we want it to be, and or as small as we want it to be. And testing it will be as hard as we want the function to be complex. So this is an example of one function here using the schema library. So here, like a function receives some parameters with a given type. Like at Nubank, we declare the types on almost all the functions, more for documentation, not for validation. Okay. And then the threading macro and run some logic here, not some non-trivial logic. And to test those kinds of functions, we are now using Clojure tests for most of it. And the thing here, like we don't use just Clojure tests. We also use that library called Matcher Combinator that's open source at Nubank that allows you to check for submaps. Okay, so we can, instead of like checking for the whole response of this function, we can check for individual attributes or for individual elements on a list or something like that. So it allows you to do less specific matchers, and it's very powerful for big test suites. Okay, and we also use generative tests using this Clojure test properties macro. So we can def a spec, so we can generate several values based on a schema. So if we have a schema of input, we can generate random examples of that schema and test against our function and check against a property here. Okay, so we do that not as much as we should probably, but like we can do that. Like there are several places that have enough complexity that we do this kind of tests. Okay, using Clojure tests. On the controllers, on the other hand, like the controller is mostly wire logic and side effects. So the problem is, like on these controllers, they will probably fetch an HTTP request or fetch something from the database, and then write something on the database or send another HTTP request to do something or publish a message. So the problem is, like controller tests will either mock everything or run everything on the real thing. So we used, like this is an example of controller function. So we fetch something on HTTP or run some business logic and then produce a message on this case or produce a message on this other case. Okay. And we used to test all the controller functions using Midge. Midge is the library we used to do before Clojure test, because it has like this RSpec-like syntax that the CTO liked at the beginning, and we probably followed that. And basically the controller test, like, it's all mocked, so it's basically you're repeating the function 2 times. So there's not much value on this kind of function of tests. So we eventually stopped doing this kind of tests. And we eventually stopped using Midge as well. It's still there because like we are not stopping and rewriting all the hundreds of tests that we have on the legacy code. But the problem is on Midge. Midge doesn't look like Clojure. It basically has this weird arrow syntax that doesn't map to the mental model of Clojure. So when a new Clojure programmer comes to the code base, we have to teach them this weird syntax, and if they put the arrow on the wrong side, they get a weird error that they don't know what to do. So we eventually moved to Clojure test and that matcher combinators library. But like there's still lots of Midge tests there, and we eventually stopped to test controllers directly, at least. And if I'm talking about the other layer here, because we test these 2 layers together. We have these adapter layers that basically declare the functions that handle all the endpoints. So the inbound HTTP request or the outbound HTTP request, the inbound message or the outbound message, the functions that handle those events. And these functions usually adapt a schema that's external schema. The wire schema can be different from the internal schema that you use, the service uses for business logic. And those adapter layers have access to all the components. So if we were to test that layer, we'll also be like mocking everything and just delegating the test. So there's not much value on testing that on Midge or Clojure test. So this is an example. So we have like here we use pedestal for routes for HTTP inbound. So we declare here what's the schema of the response of that function. We declare a handler that has access to all components, and then we run some controller logic, then adapt to a wire format and return to the customer. That's to the client, sorry. Okay, so this is an example of the adapter function. We have something similar for HTTP, for Kafka Messages and so on. And how we test this? We test it in conjunction with the controller. So to test both the adapter and the controller, we use the real version of the adapter and the controller. And the controller, since it runs the business logic, we also use the real version of those functions. We don't mock those functions. What we mock is we mock the components. So we have mock versions of all the components. So we have a mocked HTTP components and a mocked Kafka components that we can inspect and stub requests or stub messages. And the test will test a flow. So we test a flow that enters the system and gets out of the system, one flow, and we test both the adapter and the controller with that. And we test that with a tool called Savage. That's also open source at Nubank. That has this flow syntax that, think of it as being an arrow. So it's an arrow function, okay? Or an arrow macro or something like that, a threading macro, that will do step by step. And each step we receive a world map and return a world map, okay? And okay, init, the first function is usually an init function that basically starts all the components, create a new account or something like that. And then we can stub some requests, log the messages, and execute a side effect. For example, send a message that's telling that system that the bill is paid, okay? And then we check the resulting topics. So there was a message produced to the topic rulebook here that has this content. And we use these matches from that matching library, that match combinators library as well. So this is the flow. And the odd thing here is that he has this muffin world here, like magic variable that we can access the world anywhere, that we can like inspect the world and test against it, which is not that functional, having this magic variable. So we also created another library that is a little bit more functional called Stateflow. There's also open source at Nubank. That uses a syntax close to the cats library, like for the ones that know about the cats library, the monad abstract type library. Basically, every step now can bind to a variable so we can like still stub HTTP requests here. And when we issue the request, we can bind it to a variable. And then we can inspect the result using that variable. So it's a little bit more functional in a sense. So there is no like hidden stuff. It does use the state monads. That's a little bit magical sometimes, but like it's a little bit better and more composable as well. So we can have a part of the test that we can use for several, like a setup on the test that we can use in several tests. And it's also easier to inspect and do something and do some like metrics and generate. There are people at Nubank that are using those kinds of tests to draw like sequence diagrams or something like that. So they inspect the HTTP components and the Kafka components and then run the test and produce a sequence diagram or something like that, which is being very helpful for us to document it, to have generate live documentation and to debug some stuff. So it's being very promising. So this is the recommended way for people to use today. But we have several. Most of the code is using the other syntax, this flow syntax. Okay. It's not. Most of the code is not even exactly like that, because this is based on Clojure tests. There's also a version of that that's based on Midge. So most of the code still use the Midge version. But we are moving towards these two, and mostly this stateful flow. All the new code is probably using this. On the ports layer, we usually implement those ports using components, the Stuart Sierra components library. And the idea is like these components will handle the communications usually. So the Kafka component, the HTTP component, or S3 or something like that, Datomic component. So testing those ports, usually you do the library testing. The problem with testing libraries is that, like, if you're going to test HTTP, you have to issue real HTTP requests, otherwise you're not testing anything. So instead of having like so we do have like unit tests on the logic that are on those components, but to really test it, we have like just saying like these are protocols, and like these components implement those protocols. So we have one component per protocol we have. I'm talking here about the test of the library. Okay, we usually test them in production because it's the best way to test those things. We test several before production as well, but like the real test is on production. So we do it in release channels these days. So we deploy those the team that's responsible for that component, for that library. We usually issue a new version, test it in a non-critical service first, and generate a beta service. And there are some services that subscribe to that beta channel that are not critical as well. So in a week, those services will be upgraded to that version. And then we run that for another week, and if nothing crashes, we go to the stable version. So in a week or two, all the services will be on that version. Okay. We now have auto upgrade running on all the systems. Not all the services yet, but we're going to all the services to have like this auto upgrade. So if all the services run on the latest version, this is the process that we follow. And we also monitor them, and the squad that's responsible for the library will probably have a more specific monitoring to see if that new version will crash anything. And usually this is only really relevant if we're doing like big changes, like changing the Kafka version, or to implement this new monitoring, or doing something big. To do something that a little bit small, like we have like a common core library that has utility function, we don't have to follow this process. But for doing like Kafka integration, we have to. So this is the way we do it. For the services layer, this is the infrastructure. So we have to test the infrastructure. And the idea is like, in our case, the usual deployment is generating a Docker container with the code and deploying it in a Kubernetes cluster. So to test that is usually when we change it. If we change the deployment, for example, bumping the Java version or testing a new configuration on Kubernetes or something like that, we follow the same process as the ports. We do it in the least critical services first. So we do it for one service and monitor it first, and then we do for non-critical ones, and then we do for all the services, always monitoring. Because like there's no way to test it with not on production. Or like the real test is only in production, so we do this as well. We also do most of the service code, the deployment code is declarative. So if everything is declarative, we only need to test something if you're creating a new feature on that declarative testing, or if you're changing an existing feature on the declarative. So if you're just changing a parameter here, you don't really have to test it. You just like change it and put it in production. Usually it works. There's always the case that it doesn't, but like the chance that it breaks production just changing one of these parameters is very low. So the real testing is just adding new features or changing existing ones. And this repository is very powerful for us because we have like definitions here about the database that the service uses, but also how we do the continuous delivery pipelines as well. So like we basically put all the context on how to manage that specific service in an IDEM file that we can put lots of meta information there. So, and most of the engineers don't have to know how it works, which is the best feature of this. It's declarative. Just give me 10 CPUs and that's fine, and don't have to worry about it. And there's one team that knows how this works and does it, but all the 500 engineers can know how to change that file and change the deployment. Okay. And then we have the other layer, that's the context layer. So we have a few tests that relate to a business domain. And testing that domain is also a test that people usually want to do. We started having end-to-end tests. Okay, so we spin up all the services in a test infrastructure and run a test against it. But it didn't scale very rapidly. It's like having like 50 services, it's already didn't scale, right, Gabriel? The problem is like as we evolved the company, the queue to run those tests started to getting bigger and bigger, and then eventually you just queued those tests. But just cleaning it was not enough. We had to replace it with something that gave us about the same guarantees. So we replaced them to a contract testing library that we call Soshim, that only validates schemas today. So basically, most of the bugs that E2E suite caught was schema bugs. So basically, the producer schema was declaring a field that the consumer schema didn't declare, or it was a different schema or something like that. So basically, this tool, Soshim, will validate all in all the endpoints, the inbound schema and the outbound schema, and see if they match. They don't have to be the same schema. They just need to be compatible. Okay? So we follow the tolerant reader approach. So the reader will declare only the fields they need, and the producer will declare all the fields they will produce. And then Soshim will validate if those schemas are compatible. Okay, so this is an example on how we do it. So all the endpoints have a code similar to it. Okay, so we declare the schema. That's this particular schema. So if I produce a message to originated, this will be the schema on that service. And the consumer of that schema will also declare something like this. But the schema can be a different one as long as it's compatible. And unfortunately, Soshim is not open source yet because it relies deeply on the structure of our internal libraries. But if we're doing the code here, it will be basically having this code for all the endpoints. Basically, we generate a producer schema and validate against the consumer schema. So do a property test here, a generative test of this for all the endpoints of the system. And Soshim guarantees that this works. We will open source that eventually. We have to extract the generic part of this protocol. But in order to be able to do that, we have to have an extractor code that will be specific to your organization as well. So this is not that easy to do. But as soon as we do that, we will publish it. But it runs for all the endpoints and catches 90% of all the bugs that E2E catches. And it doesn't take like 20 minutes to run. So it's a good thing. But we also have the other 10% of bugs that this doesn't catch. And we have production for that. There's no problem. There's one way of catching those bugs is like we do canary deployments and see if those bugs reach production. Problem is there are some bugs that we only know about it 1 month later, that this doesn't help. So we also use that business domains concept to create a set of those services that have a high cohesion between them. And we started creating what we call acceptance tests, for the lack of better word maybe. That's basically tests against 4 services, not 500. Okay, so the problem with E2E is that it doesn't scale to 50 services. It's very hard to build a suite for 50 services, let alone 500. But if you have 5, it's okay. Like you can manage 5. You can count 5, so it's good. So basically, you use something like, we declare a depzDN file that basically hard links to all those services. Okay? And we use that tool that I showed. So before that, like we start one system per service on the same JVM. Okay? Basically, hard links to the repositories. We start a system per service, and we use a mocked version of Kafka that is a channel, for example. When we publish a message, we publish to that channel, and all the services will consume it on that channel. So it basically is a a mock Kafka, but some better mock that does actual stuff for those two services. And also there's an HP component that if the outbound service is double entry, in this case, it will do an actual call to double entry. If it's other one, it will stub the request. But if it's double entry, it will call the handler on double entry. Okay, it's basically, we hard link those two services, and all the rest is still mocked. Okay. And then we can write the same test that we write for the integration, the adapter test that I show you, with the difference that now I have to specify which service I'm talking about. So the originate, I'm originating an account on a specific service or on all the service. And when I'm doing this balance sheet, this balance diff is on the larger service. When I'm closing in the bill, I'm closing the bill on the billing service, and so on. So basically, I select the service I'm talking about, and then I use all the tools I have available for the other kinds of tests. So basically, I can test a flow, a more complex flow that spawns several services, but it's more controlled than having a E2E running in a test environment that I cannot mock anything. I still can mock something, and I can still inspect something that inside a service, but I have 5 services to care about, and it's way more complex to build that than building the normal one service test. But for some flows, this also helps us catch new bugs or something, and we also use that for building new features or building new platforms. We're doing that mostly for now we're in a process of extracting platforms out of the system. Okay, so now that we really understand how credit cards work, we have the ideal platforms. So to extract those platforms, we are creating flows like this to test that new platform is working. So it's being very helpful. We are not running that on the pipeline yet. We will eventually. But this is a little bit harder to maintain as well. So, and this is the overview I had for you. And this is how we test all those things. And how about you? So now opening for discussions and questions. And thank you very much for listening to me. And Nubank is hiring as always. So if you want to participate on that journey, there's the link there. So questions, okay.
First question. You mentioned people using the DAF flow as a way to draw sequence diagrams and comparing. I guess it's also kind of tooling that you guys built around it. Is that part of the stateflow, or is it a separate tooling?
It's a tool around stateflow. Yeah, okay. Yeah.
But do you mind repeating the question? Sorry.
Yeah, repeating the question is if that tool that I mentioned a tool that generates a sequence diagram over this. This tool is still under development. It's not stable yet, but the idea is it runs around the stateflow. Stateflow, it generates meta information on the steps that it runs, and we also inspect the components, so the HP components, the Datomic component, and the Kafka component, and we use that as the message that the state diagram and the sequence diagram uses. As soon as this is stable enough, we probably publish it. And they realize in a tracer protocol and open tracing protocol and stuff, so it's good. You were going to.
Oh yeah. When you say inspect, you got a few of these services up, is that a human sets a breakpoint and is looking at the state of the world, or inspect is more logging these services sort of that you're testing?
inspect. The question is like, what is the inspect if it's like a breaking point or something, or if we can look at the state of the system. We have two kinds of inspect. We can like query the database on an inspection if we want to. The database is a memory database, is not a mocked one. But on HTTP and Kafka, for example, every new request or every new message is stored in an atom, and we use that to inspect. So basically, the mocked version also accumulates all the calls, and we use that.
Like if a test fails, you're like breakpointing and seeing what the heck's going wrong.
Yeah, yeah, we could. If we have access to the world, we can inspect what's going on. Yeah. Okay. Okay.
So if I understand the relationship between the types of tests correctly, is it true that now that you've retired the end-to-end test, there's essentially no test anywhere in your business that runs like a real Redis or like a real Kafka underneath it? That everything above the sort of like mock level is these schema comparison tests, and everything else is left to the live system?
Yeah, yeah. The question was like, if you do retired A2E tests, yes, we don't. We actually have an environment that people can do manual tests, and also like they can like change the code in place and run manual tests, but we don't have like automatic pipeline tests that run in a test environment. We don't have that. Just production. Yeah. Do you think? Yeah.
Yeah. I mean, so from what I gathered, you guys have a lot of from switching from Midge to a lot of these huge organizational efforts, and are able to maintain some guise of agility within that. And I'm just kind of curious around what sort of communication, what kind of organizational, organizational infrastructure, people type stuff. Does keeping this much malleability within an organization as large as Nubank, how much overhead is that? Does Clojure help you guys with that sort of stuff? And what sort of processes have emerged around making sure that when you do want to instantiate some sort of priority, like we want to get away from Midge, how does that become enacted? What is the organizational procedure of switching everyone over to that, or to this new priority or this new goal? Because it seems like you guys are able to do it, and that is like a really difficult problem.
Okay, so trying to repeat these questions because this is very, very hard. It's question about like in our organization as big as Nubank, how we do this kind of like architectural changes over the services without breaking everything. The answer is like we usually don't break anything. Since we have like new services happening all the time, what usually happens is we change the ideal architecture, and the new services start using that. Yeah. And if you wait long enough, most of the services will be on the new architecture. And migrating an existing service to that new architecture, for example, migrating from Midge to Clojure tests, like we don't just do it. Yeah. We don't do it if a service is changing a lot, right, and we have like new people on that team, and so maintaining like a hybrid of Midge and Clojure tests. Like we usually don't do both on the same service.
I see.
So
it is atomic at the service level.
Yeah.
So someone has received sort of a task of like, we want to take this service and from Midge to Clojure.
Yeah. So usually the same service use the same style, except for the really old services. But like we usually have one. So if the service is Midge, if you're adding new stuff to that, it will be Midge, right, until we decide to migrate it all. When we do decide to migrate is when we have a team that's responsible for 5 services and only one is Midge. So if there's a new person on that team, it's very hard to them to like, okay, most of the code is Clojure tests and this is easy and it's good, and then they have to write something on Midge. So we just run a test to migrate everything. We are also experimenting on migration tools. So Clojure rewrite, I believe this is the name of the library, Clojure CLJ rewrite. So we are writing scripts that can migrate from image to Clojure tests, or for flows to stateflow or something like that. The problem is like it doesn't work on all the cases, especially because like the way you write tests using monads and not using monads is very different. so it doesn't work all the time, but like it helps you to get far enough so you can do just the last piece.
And just kind of a last curiosity is when you decide to, like, you have a service and you're saying, okay, one, you know, of a set of 5, one of them is still midge. Does that priority of you know, that boiling point of when that becomes a problem is you know, where in the organization does that come from? Does that make sense as a question?
Yeah. The question is like where in the organization this changing architecture comes from. It's usually from the team, from the development team, because like if they are like having too much trouble in changing that service, like if the service is not changing much, there's no point on doing that. But like if we expect to change that service a lot on the short future, we can do that.
Thank you.
No problem. You too.
I was curious about the 10% of those cases that you know, don't get caught by the because I was involved in testing a system which does about 8 billion requests per day, and with like each request generating tons of other events in a Kafka cluster, so quite similar. And the 10% bothers me a lot as well. So as 95% of statistics they're made on the go. It's like it's not actually 10%, but but the thing is like we do have a good coverage on the service that we are changing. So most of the bugs are caught by unit tests or for the integration tests, and because of our customer base, if a bug hits production, we find out very quickly as well. So, and since we deploy very often as well, if a bug reaches prod, is usually because of a change that happened on the same day or on the day before. Or there are a few cases that we only find out about the bug a month later, but like most of the cases we find out like very fast on production. And if we are fortunate that the bug is an exception that generates lots of dead letters or errors in prod, if you are not that fortunate, the customer support will flag us and we find out. Yeah. Just I'm not sure who was first. Like, okay.
Do you have tests that are exercising the UI, like Selenium test or something? And if so, are those running on a production environment as well?
Okay, so the question was is if we have like UI tests as well. We do have some UI tests for the mobile. It runs on the release train on the mobile part. It's not a production test. Yeah, it's not a production test. I'm not that involved on the process that they follow, so I don't have much detail about it. But they do have like some like logic tests, like presentation logic tests, and also some like screenshot tests or something like that. And they do have a part of that on the release pipeline. But we also follow a rollout process that we first roll out the new change to just the Nubankers, so just the employees first. And since we have like 3,000 employees, so we catch lots of bugs on that. And we wait for a week, and then we launch for the beta group, and then wait for another week and launch to the whole population in a percentage base, rolling out. So we usually we catch most of bugs doing that as well.
Does that apply just to backend or just to front end or problems?
The bugs can happen in several
Sorry,
things.
I mean
Like
the early access channel for the employees, is that switch something that is only recognized by the mobile app, or is that something that, say, a microservice knows, like, oh, I'm being accessed by this user, go to this version?
we do have like several feature flags and rollouts. So, and we also have like some way for the server to push code to the mobile. So there are several screens on the mobile that are defined by the server. So we don't need a release on the mobile to do that, to change something. So usually the backend doesn't know about it, but the backend for front end does. So we have like a service layer that's on the front of the mobile.
So they could, but they don't.
Yeah, yeah, they could like. But if you're doing like if statements on your code based on a app version because or the feature flags, there's usually something wrong. We usually do the turn off the whole feature, not just if the request got to the service, it's because it's allowed to do, and we don't have to have the check on the backend, but we do on the backend for front end. So, you?
Yeah, just wanted to kind of hear more specifics about the scalability issues you ran into with the end-to-end tests, and I guess you had mentioned that there's a queue developing, and I guess the naive like solution to that would just be like add more test environments or add more servers or something like that, but I just kind of wanted to hear what the problem was with that naive solution.
Problems like, as long as we have like 10 developer teams, the way like if you're testing against all the changes, it's very hard for you to know which change caused the bug. So we basically went to a route where we test the changes of one team. And every team has a set of services that they are owners. So for example, that team owns these 5 services, and one of those 5 services changed, and that triggers the end-to-end. And the problem is if we have to maintain 10 test environments, and when we go to like 50 test environments and 100 test environments, this becomes very costly. And this also doesn't solve the bug very much because, okay, this team was promoted, so like that passed the end-to-end test. So now I have to put that new version as the main version for all the other 49 teams, and then run the tests against those. So handling this is not very easy. And the other problem is like, if we have 50 teams, imagining each team having 100 end-to-end tests. So you have like now 5,000 end-to-end tests, and all of them, each of them take a second to run or something like that. So they become very flaky and very slow to run as well. So and the benefit of running them is not that great because, as I said, like 90% of the bugs was schema bugs. So checking schemas is more efficient than running the end-to-end tests. We experimented on contract-based testing as well. That's basically a way for you to link those 2 tests between 2 services, but maintaining that was terrible as well, so we eventually gave up, and that was it. So you please.
In terms of all these services communicating and having to check schemas, do you consider like thrift or protobuf or something, some sort of schematized binary format?
The question is if we consider thrift, protobuf, or any other protocol that has a more strict schema. The problem on doing that is that you now have a strict schema that both parties have to accept. And we follow the tolerant reader approach that I can evolve the schema on the producer side freely without having to change the consumers. And like for synchronous communications, protobuf and thrift will work. But most of the communications are async and are through Kafka. Yeah, we can use Avro schemas or something. it doesn't really solve the evolution of the schema, I guess.
Avro has schema built in.
Uh,
Might be a different kind.
I think like we could experiment on that. We took this approach that the validator is the Soshim library, so this is working fine for us so far. So we don't have the net gain on doing that is not that much now. If we are moving to Avro, will be for another reason. That's the compaction of the message or something like that, because we still use JSON as the message format, which is not that performant, to say the least. And like we are probably this year we're moving to a binary protocol, probably Avro or something like that for the messages, and probably something like gRPC or something like that on the HP or on the sync side. But this is not defined yet. Okay, something you just. Sorry.
So I was wondering, you said that you try to catch a lot of bugs in production. I was wondering if that's production in Mexico or Brazil. No. So that actually was my question. So I have a slightly tangential question. If it's too tangential, I can just talk to you afterwards. But you use through quite a few of your systems Datomic, and I'm wondering if you can talk to us a little bit about the performance and choice of Datomic, how you guys use it, or the trade-offs.
Okay, so the question was like if you test some production in Mexico or in Brazil. It's both, so it probably breaks one of both, if not both. But the problem is like only Brazil has a good enough customer base, like a big enough customer base so far. Mexico only have like tens of thousands of customers, so it doesn't catch much bugs. And other is like talking about like Datomic performance. So we usually do one Datomic instance per service. Okay, and that usually takes care of like scalability overall, because most of the services don't have much scale, even though we have like 20 million service customers or something like that. Not all the services have that scale. Not all the services are used by all the customers. But there are some services that do have a big scale, but there are some services that scale with the transactions. So what we do also is we have a sharding infrastructure architecture that we have like 16 shards today. So we don't have all the customers in a single shard. We have like 15 groups of shards per customer. So there's one shard with a million customers, another shard with a million customers, and so on. This also helps with the scalability. And the thing about Datomic is the reads scale very, very fast because they are horizontal scale. We use the peer model on Datomic. And so if we want to scale horizontally, we add more nodes and more memory sometimes, and it works. The writes are sequential. So if you have a high throughput system on Datomic, you might have to optimize it somehow. So we had to optimize some services for write throughput. We can add like bigger machines for the transactor or something like that, but it only gets used so far. It doesn't solve all the problems. So we also like we had to do like time sharding some services because of that. So when the database gets bigger and bigger, the transactions start getting a little bit slower. It only is slow enough after like a huge amount of datums, but like it eventually gets there. So we did time sharding to solve some of that. And if it's constant pressure, also we had some issues with that. So if there's a service that runs like 100 transactions per second for 24 hours straight, this will be a problem. So if the service does like a huge burst, but there's a period that it's mostly okay, it's usually fine. But if it's constant pressure,
It didn't work that well for us in some of the databases. It might be because of the writing pattern, but it might be because of something else, but that was our things. And also, Datomic doesn't work for aggregations, so you can do like specific customer queries very well, but you cannot do like give me the average transaction purchase for this particular. This doesn't work on Datomic, so that's why we have the ETL for that. So we basically dump all the transaction logs on the ETL and query a SQL database that can do that. So, okay.
One more question. Do you do code reviews, and what role does that play in the overall quality?
The question was about code reviews. Yes, we do code reviews on pull requests on GitHub, and every team follows its own protocol, but it's usually you have at least one approve before shipping the code. There are some repositories that are blocked until you do that. Some are not, but like we usually do that. We usually have like also pull request checks as well, so we have like a continuous pipeline on the pull request as well. So we have a process on that.
In terms of like the meta level, I guess this accidentally piggyback, sorry.
No problem.
How the code and the tests themselves are written, do you have like either rules or guidelines about like mandatory coverage, or like rules about what kinds of cases sort of must be considered before a product ships? Or could a team, if they had to, say, we don't feel somehow this is testable, would that be considered either acceptable or there are hard rules against it?
The question was if we have like rules about what kind of changes can happen or test coverage or something like that. We have one rule is that the team that ships that code also operates that code, so that code in production. So usually the teams that owns the service that break the most have like stricter rules, and that happens naturally. We don't have to enforce it. Because otherwise the people will be just doing like on call all the time. But it's basically up to the team. We usually do this pull request review. Usually when you write a pull request without tests, it doesn't get approved. So the teams do a good work, a good job on maintaining that.
Just a follow-up, since you have the benefit of such a large organization, is there any like statistical analysis suggesting that certain patterns of development lead to lower bug rates than others?
Sorry, I didn't understand the last part.
Is there any sort of like analysis of change by your various teams that show that like certain patterns of test coverage, for instance, like have a certain effect on bugs?
So the question was if we have analysis on the change pattern that leads to bugs or something like that. We started doing something on that now, like recently, like just like end of last year, that we have like a really mature monitoring platform that we can that we started pushing to the ETL the metrics as well, so like the real-time metrics pushed to the ETL, so we can now run those kind of analysis. But this is not established yet. But we could do this kind of like the problem is like we have to add more probes still on the process to do that. We don't have all the probes, but we can we will start measuring like lead time and like time to commit to production, and then if we start measuring that, then we can like correlate that with an increasing error rate or something like that, so we can do the second part. So we start doing that like this quarter or this semester or something like that. Okay.
Awesome. Oh,
okay.
Do you have more questions?
One more question, and then we can. Sorry.
Really beautifully constructed.
Thank you.
I'm sort of curious if you have hired engineers who've worked on other banking cores, and how much are their minds blown by working on yours?
Question is if we hire people that already worked at banks, and how hard the minds blown or something like that. We did do that, but this is not a big portion of the engineers we hire. We don't expect people to know about finance or banking before, or even Clojure before joining. So we hire general level engineers. But like at least the banks in Brazil, they have like very hard processes. So Nubank, it's not everything free anymore, but like it's a way lighter process, and it's way more fast and way more autonomous than most banks. So people are usually surprised by that. Okay.
Perfect. Thank you.
Thank you.